Hello and welcome everyone to my channel Code with Ease by Varsha. So we are discussing solid principles and today we are going to discuss the L of solid, which is Liskov Substitution Principle. So let's try to understand that with a simple analogy. So Liskov substitution is supposed to be one of the principles which is a bit complex to understand because of the traditional definition which is given in the computer science books. We are not going to go by the traditional definition right now. We are going to see that in a while. But let's try to understand in simple words what it means. So let's say there are a couple of kids as we can see in the picture, and the kids are A, B, C, D, E. There are 5 kids who have come along to bake a cake for a birthday party. But the kid number C fell sick. So what C did is she sent her sibling to join the rest of the friends to bake the cake. But the sibling is younger to C. So let's say all of them are close to 10 to 12 years of age. The sibling is only 6-year-old. So how many people we have now? We have A, B, D, E, and instead of C, now we have sibling, let's say X. So these are the 5 people who are working. So C had one duty to mix the flour and the milk and the sugar. Okay, so now because C is unavailable, her sibling X is going to take care of that. So what it means, I now have A, B, X, D, E, these 5 people, and X is working on behalf of C. So Liskov substitution principle, what it tries to say that if there is an entity and that entity has certain child classes or child modules, each of those child modules should be able to work on behalf of the entity whenever required. Just as in this case, X, the sibling who is younger, but she is working on behalf of C because C is not well. So what is the expectation out of X? If they want to bake a cake in a certain time period, X is supposed to perform at par with what her sibling has done. Even though she is young, even though she is not that much experienced as C, but the expectation is that only that you have come on behalf of your sister, so you have to work in accordance to whatever she had the capability of working. Maybe the speed should match, maybe the efficiency should match. So all of that needs to be taken care of. So Liskov substitution principle says that same. Any software entity, if there is a software entity and there are several child classes or child modules, each of those child modules have to be able to substitute for their parent whenever required. Now, if X is not able to meet the expectation of what is expected from C, what will happen? The baking of the cake will take longer time. There might be errors. That is the most important thing, like the most dangerous part. If the cake burns or there is a completely terrible taste of the cake. So errors, right? So errors is the key word over here. Whenever there is any error also in software system, we become very wary of that. So that is the reason why we have to be able to obey this principle called Liskov substitution. That's work in place of your parent module or your base module, whatever, but work accordingly, work properly like you're supposed to work. If you're not able to work properly, don't come in as a substitute of your parent. That's it. So here is the definition for Liskov substitution principle. Objects of the superclass should be able to be replaced by the objects of the subclass without affecting the correctness. So like we gave the example of the cake baking, when X is substituting C, she should be that much capable that she is able to replace her sister in the process of baking the cake without affecting correctness. Means what is the end result? What is the outcome? A proper cake should be baked correctly, right? So the end result should not be compromised. So that is what is meant by this. There's one more way to define this also, that subtypes substitutable for supertype. It means the same, that the subtype should be able to substitute or be able to replace the supertype. So this principle is actually important to know when we talk of inheritance hierarchies in object-oriented paradigms, class, base class, child class, all of that. So in order to document the inheritance hierarchy well, this principle is important. And as we know, in case of inheritance, what is the relationship between the base class and the child class? It is a relationship. So Liskov substitution principle also says that it is not sufficient to only satisfy the is a principle. You also have to be able to satisfy the is substitutable principle. We will see a real life example in a while, but what I'm trying to say is if there is a class A and then it is being extended by class B and C, which are the child classes, the functionality of A should be able, like B and C, the child classes should be able to replace the functionality of A. If they're not able to do, means they're violating the Liskov substitution principle. Now let's see the example. We'll take an example of a bank. So in bank we have accounts. So let's say there is a base class called account. Now this base class called account has two very simple methods or two simple functionality. One is to deposit the amount that we want, and then to withdraw the amount that we want. And we know that all of us have bank account and we try to deposit money, we try to withdraw money. This is the basic functionality that we try to do with our account. Now, account can be of two types. Primarily, we all have savings account or salary account, and those who do business, they have current account. Okay. Now, the base classes account, savings and current account are the child classes, and the relationship is a relationship, like we said. So savings account. Okay, one more thing is there is a client. Who is the client? It can be the ATM, it can be the users, the customers like us. The client is talking to the base class. Okay, so the expectation of the client is whatever functionality is defined in this account class, whoever is extending the account should be able to deliver the same functionality. So savings account, we wrote the class for this, we overrided this method. So whenever deposit happens, we are updating the core logic behind that, and withdrawal is working fine. So far, so good. My withdrawal deposit works fine. The functionality looks good whenever I am switching between savings and current account. Where is the problem? The problem will be there is a third type of account which is also extending the account class. The name of that account is fixed deposit, FD. That is also a type of account. We have a different account number for FD. But why is it a problem now? In fixed deposit, there is a lock-in of the fixed number of time, like 1 year or something. So if there is a fixed deposit of 1 year, I have deposited the amount into it once, and I cannot withdraw from it whenever I want to. If I do, that will be premature withdrawal. If only I have to withdraw, I can withdraw after the maturity is reached. So that is how FDs work. Now, why is this a violation of LSP in this case? Because deposit is fine. Whenever I try to implement the withdraw method in my FD class, I have no mechanism to withdraw the money at any given point in time, like I can freely do in case of savings account or current account. So what I have to do? I have to return some exception or an error that withdrawal is not allowed in FD class. And that is where the problem arises. Think again in terms of the baking example. If the child called X said that I cannot handle the mixing of the ingredients, I am not capable enough to do, give me some other work. So then what will happen? As a result of this, the entire plan will get jeopardized. Everyone had some different responsibility. All the children had each single responsibility, and because of one child not being able to follow that, all the plan is getting jeopardized. So she is not able to properly substitute for her sibling. In this case, fixed deposit. So when this client is trying to call the account classes functionality, I went to an ATM, I am the client, I am trying to withdraw the money. But when I'm trying to withdraw money using FD as the instance type of account, I'm getting an error that no withdrawal allowed. But my account class is supposed to return the account class's correct functionality is to give me certain result that I have 100 rupees, I made a deposit of 100, and now I made a withdrawal of 10 rupees. So it should give me 190 as my balance. But that functionality is not achieved because I introduced the fixed deposit class, and it is giving me an exception, which means what? It is not behaving correctly. And that is what our definition was. The subtype should be able to substitute for the base type without affecting the correctness of the program or the algorithm. And it is not doing that. So it is not substituting for the base class correctly. And that is a problem in this case. So how can we fix this? So what is a workaround that we can use to fix that? So like we had the account class, and the account class had these two child classes, the savings and the current, with the deposit and withdraw method. What we can do is, in between this, we can introduce one more class which we can call withdrawable account. Okay, withdrawable account. And the methods of account class, instead of deposit and withdrawal, let's only keep the deposit method, because withdrawal is subject to change. So we will only have deposit. Withdrawal we are not going to have. Withdrawal, this new class withdrawable account, is going to have rest of the functionality of related to withdrawing. So now, instead of inheriting from the account class, what I'm going to do is I'm going to inherit from the withdrawable account class, the savings and the current account. So account class, from here the withdrawable account class is being inherited, and the fixed term deposit or fixed deposit class, and the fixed deposit class is going to extend or inherit the account class. It will have no relation with the withdrawable account. Why? Because fixed deposit is not a withdrawable account. So we have done a clear separation of concern, that we have segregated the accounts. Firstly, we have removed the withdraw method from this, and then we have made a different account only for savings and current class to extend. And fixed deposit is inheriting the functionality from account. So now what is going to happen? I'm again having the client. Now client knows what? If withdrawable account is giving me the functionality to withdraw money, the savings and the current account should also be able to justify this functionality. What is account method class doing? It is trying to justify for deposit. My fixed deposit class is also expected to justify the deposit method. So clear separation of concern is there. There is no room for any error or any unexpected occurrence. It is going to perfectly work now. So that is all about the Liskov substitution principle. In order to model good inheritance behavior, we have to follow Liskov substitution principle. Wherever we can see that the inheritance is not working properly, like I said, the is a relationship is not enough, is substitutable relationship should also be satisfied. If it is not satisfying, it is a violation. Try to segregate, try to rethink the design where it went wrong, and try to make sure that the LSP principle is satisfied. So that is all about today's video. Thank you so much for watching. See you guys in the next video.